Okay, so question 10. So it says, after intensive logging, most of the trees along the stream have been removed. Which of the following water quality changes would most likely occur downstream after logging? So tell me, I guess like Richard or Caitlin, like if you want to explain kind of your thought processes behind this question.
So I know that like taking into account the concepts of soil erosion, like when you take out a bunch of trees and there's going to be increased soil erosion. Um, so yeah, that would be like my go-to answer if it was here, but it's not, and I guess I don't have a clear understanding of how water temperature or dissolved oxygen or like coliform has to do with increased soil erosion. That's where I kind of got tripped up.
Then Richard, what do you have thoughts on this, or have you started looking at this one yet?
I haven't looked at the questions, but I would honestly guess A because there's maybe like some sort of like thing with like temperature and like removing trees and how changes the temperature of the soil, I think.
Wait, tell me, say more on that. Say more on that.
I think like in one of the Unit 5 videos, there was like if you remove like the trees or like vegetation, apparently that like absorb apparently like plants and vegetation absorb like the temperature or something.
Yeah, so that's exactly it. So it is A, increased water temperature, and it's like it's what you're saying, Richard, where like if you walk into a place with a lot of trees, it's usually cooler. And it's because yes, the plants absorb heat, but also they act as like a shade. So it's really not that complicated. It's just like the trees act as shade. So without the shade of all of these trees, like everything just gets hotter. Um, which, so like the soil gets hotter, the water temperature gets hotter. And so that's why it's A, where it increases.
Oh, okay, I see.
Yeah, but the other questions are surrounding erosion. So like increased dissolves oxygen, that wouldn't be the case because erosion, like the more sediment you pump into something, there's less dissolved oxygen. And like same with this, there'd be an increase in dissolved solids. So it would be A.
What's fecal coliform? Is that just
Uh,
like feces?
yes. And so their reasoning for it is that it doesn't like like there would be a decreased, it says a decreased infiltration of solid waste due to runoff. It would increase the amount of fecal chloroform in the water because you're
Oh,
allowing more
okay.
sediment to like run into the river.
Okay, okay. That makes sense.
Yeah. Okay, what else are we thinking? And so even if you don't have like a particular practice problem, if you just have like general certain topics, you're like, this didn't make sense.
I had a question on Unit 4, the MCQ, question 14.
You said 14, right?
14, yeah.
Okay. Let me share my screen again. 14. Caitlin and I talked about this last time. Caitlin, do you want to give a stab at explaining this one? So, oh, go ahead.
Oh, um, hold on. Let me just. You can go first. I'm gonna like break this down in my head first and remember what this is.
Okay, I'll set it up so that you can explain it. So it asks you why the Atacama Desert has a consistently arid climate. And so Richard, I don't know if like there's a lot of vocab, but arid means like just like super dry, right? And so it's right here. So they give you a bunch of options. So I don't know, Richard, if you want to kind of like maybe talk through what it is that you felt like you got snagged on, or what doesn't make sense.
I think it was like how because like some like part of the land is next to the coast, it should be like more wet and more moist, but like this is like there's a desert there, which kind of confused me because that's near like the water, I guess.
Yeah, and you also want to notice that there is this giant mountain range that runs along South America right here. Um, so Caitlin, I don't know if you have any like explanations to add to this.
I think my first thought just goes to like process of elimination. So I guess A would kind of be like the one that I would choose because like the windward side is like near the coast of the Andes Mountains, but like kind of like what Richard said, that would mean that the the desert would have to be like have more moisture. But I think the most important thing to take away from this diagram is like the currents. So obviously from D, there's like really no difference because both sides of the coast have water. And then the rain shadow, kind of like something to do with rain, but then again, that would be like it would have more moisture, which is like the opposite of an arid climate. So it would be C, the cold Peru current brings dry air to the coast, and that would like wash away or like redirect a lot of the moisture that would be coming onto the coast. I think, if I remember correctly.
I was kind of confused because like the Peru current, like how can we tell that it's a cold current?
Yeah, so okay, so it is the rain shadow. Um
Whoops.
no, it's
Oh
okay,
wait,
Caitlin. No, it's okay. So it is the rain shadow, and this is like a phenomena that you just have to remember. So a way you can think about it is that like when water goes over a really tall mountain range, it like as the so the air has to like rise over the range, and so as the air rises, the it becomes drier because the water rains on the side of the mountain where the air is coming in, and so then because there's a lack of moisture in that air as it goes over the mountain, the other side, that's like the shadow that's cast by this giant mountain, it's this dry shadow. Um, and so that's like when you have big mountain ranges, like in California you have the Sierra Nevada, right? And it's super lush and green on our side, on like the west coast side, right? You have like the Bay Area, super lush, all of this area super green. But then I'm not sure if you've ever been on like the east side of the Sierra, which is like the other side. But it's like it's a desert, it's like this like really dry, super does not get much precipitation, and that's because like as the rain as the air comes in from these like ocean currents, it goes over the mountains, and then on the other side it's super dry.
wait. So like the moist side is on the east side of the Andes Mountains.
So the moist side is on the east side, and I think that has to do, so why that is, I think, from what I was reading up, is like you see like the south equatorial, like the air that's going to come from the equatorial range is going to be much warmer. And so like when that comes in, it's going to be warm and wet, and it comes in and it rains on this side, and then it keeps going over to create that rain shadow. And I think like the principle that the APS wants you to know is that the rain shadow occurs at like the foothills of really large mountain ranges. And they want you to be able to identify that. Does that not sit well still?
Okay, but okay, what about the like the currents from like on the left side, on the west side?
So the South Pacific.
Yeah, and the Peru current. So what role does that play?
So the South Pacific, like, okay, so a rule that we want to remember, that we always want to be remembering here, I'm going to type it in the chat real quick. When there's cold air, okay, when there's cold water, there is cold air, and I'll explain this after. Cold air, which means, oh my God, is that high pressure? I even get this mixed up sometimes. El Nino and La Nina. 1 second.
Is it the low pressure, warm air with more precipitation thing?
Yeah, so cold air is high pressure. Or is that right? I have to look back on my slides.
Yeah, because
okay.
cold air sinks?
Yes, which means clear skies, right?
Mm-hmm.
And then warm water leads to warm air, which leads to low pressure, which leads to precipitation. Okay, thank you, Caitlin. Okay, so these two things I should have put. So this is like a part of like atmospheric earth science that we want to memorize. So like when you're taking the test, if it's online, like keep it on a note card near you. Like, so when there's cold water, which we know like near the Arctic, there's cold water. So near the poles, which means that the air is just colder. And that creates a lot of high pressure systems. And then those high pressure systems, like usually it leads to like clear skies, no precipitation. So when that comes through up like near Peru right here in the Atacama Desert, that's still like, it's this cold air that's sweeping through and it doesn't drop much precipitation. On the other hand, on the like east side near Brazil, you have this warm air coming in from the South Equatorial Range. And so that warm air creates low pressure systems, which make precipitation.
Okay, so like the west side would always be like that dry sort of like no precipitation area.
Yeah, and like not as a strict rule, but that's like an overarching like blanket rule is that like that side, yeah, there's just less precipitation inherently than the east side.
Okay, that makes sense.
Cool. Unit 4 can be a little, I think Unit 4 is probably the one that is like least logical and the most technical. Thankfully, it's just one unit. But yeah. Cool. Thanks for helping me fumble through that explanation, yo. Okay, so, oh, and then Richard, this rule right here will help you make sense of the Hadley cells. It also helps you make sense of El Nino and La Nina. So anything with like the atmospheric stuff.
Isn't El Nino and La Nina when like the things like the currents go backward in a way?
Yes. Yo, Caitlin, do you want to practice your Unit 4 knowledge?
Oh gosh. Sure.
Okay, why don't I pull up my slides on that? So Richard, would it help if we all went over El Nino and La Nina right now together?
Sure.
Okay. Oh my God, where I think it was in Unit 4 overview. Maybe this one? Yes. Oh, maybe the next one. Let's see. Okay, so Caitlin, which one of do we want to go through like normal El Nino and La Nina conditions? And I'm gonna try to explain it to Richard.
Sure.
You,
I'm like
it's
blanking on this.
it's okay. I'll help you out as we go. Like, yeah, whatever you feel comfortable with.
um, let's see. So I guess in normal conditions, there's like currents going from South America to Australia, which brings a lot of like precipitation and is good for like the agriculture over on the Australian side. And then that also has to do with like the ocean currents and brings and recycles that warm water over like in between South America and Australia. And because there's warm water, or warm air, then it causes a lot of rainfall in that region. Um, yeah, I think that's all I can explain for now.
Nice, Caitlin. Yeah. So one of so like how do I say? So what causes this is the trade winds. Excuse me. So the trade winds center around the equator. So like Richard, to orient you on this map, it's like we're almost looking at a cross section of the earth a little bit. And so you're seeing the ocean underneath here. So the sun is like super concentrated at the equator. So this whole equatorial region has warm water. But because of the trade winds, the winds like blow the water, the surface water, mind you, just the surface water over to the Asia, Australia region. So then you have all this warm water that pools. So that's like a normal year that's not El Nino and La Nina. Like Caitlin was talking about, since all of this warm water pools, she's saying that like, you know, when there's warm water, there is warm air. And so like this said, with warm air, it rises, creates low pressure, and there's rainfall. So that's just like a normal rainfall year. And then also because you're displacing the water to one side in Asia and Australia, you're also pushing this water underneath here up towards like California, South America. So all of this cold water here gets pushed up, and it's also cold water in the ocean is where it's most nutrient dense. So it's good because it kind of upcycles all of this nutrients over to like our side of the world. Okay, so that's like a normal year. And so obviously there's going to be colder air over here, colder water, so colder air. So there's more clear skies. Does that make sense in a normal year, Richard?
Yeah, that makes sense.
Okay, so then Caitlin, do you want to try to explain El Nino? Oh, well, El Nino and like what's happening on like a not so normal El Nino year?
So basically, it goes in like the opposite direction. I forget what causes it. But basically, the currents go in the opposite direction from Australia to South America, and and this kind of makes it so that like the warm air is a little bit more spread out. So there's like not as much rainfall pooling in one specific location, kind of like spreading out through that whole region, or like not raining as much. And then with with like the cold currents at the bottom, then they're also like moved to the other side, which means that all of that like upwelling of nutrients that was going to the South American side is now like a lot less. And so that means that there's like less fish, less like abundant algae on that side, and it's like moving towards the other side. So, yeah, I think.
Would it like I remember like from what the one of the videos that like there would be more fish on the Australian side because of this, but like according to this, it just looks like the warm like the warm water is just being spread out.
Yeah, I think I'm not sure what the video said because I don't watch all of their videos, but I think that probably what they're saying is that there's more nutrient that dwells on this side than a normal year. So I don't know if they're saying that there's like actually more nutrients on the Australia side than there is on like the Americas side, but I think in reality it's just that like there's more than a normal year. Does that sit okay with you, or does that still not make sense?
Yeah, that sounds good.
Okay. And then also like just because my brain, I can't memorize things, I have to have logic. So the reason that like there's so much more nutrients down in the lower parts of the ocean is just because there's so much life on the top parts of the ocean that nutrients is limited there because there's so much competition for it. But because there's like less living things like towards the lower parts of the ocean, there's just more nutrients available. Okay. All right. So yeah, so then I have all of these notes of basically what I've gone through is that like, you know, this part's like what Caitlin was talking about, where like the Asia Australia side, there's just like less stronger rains that season. So, you know, that can like hurt the crops or whatnot that year. And then El Nino is also usually a good thing for like the Americas because we get more rain. We get more precipitation over that winter. Okay. Oh, and then I threw it in the chat. Like the reason that the warm water is kind of spread out, Caitlin, like that Caitlin said, it's because the trade winds are weaker for reasons I'm not really sure, but it's a given that the trade winds are just weaker during El Nino years, so the water kind of drifts. Okay. So La Nina is when the opposite happens. So Caitlin, I don't know if you want to talk about this one.
Well, okay. So compared to like normal years, the trade winds are a lot stronger, like it says. So that means that there's a lot more, like a lot more upwelling on the South American coast because the trade winds are stronger, and there's a lot more precipitation on the Australian side. Um, and yeah, I think that's it.
Yeah, that is it. Thanks, Caitlin. That was awesome. Yeah, so that's El Nino, or La Nina and El Nino in a nutshell. If that makes a little bit more sense, Richard.
So La Nina is just like stronger, like a more strong version of normal conditions.
Yeah. Yes.
Cool.
Yeah. So also they're gonna ask you like weather questions. And just know that in the winter, like during La Nina, it's gonna be like a lot drier. And over here in Australia and like the coast of China and Southeast Asia, it's gonna be like a lot wetter and like stronger monsoon seasons. Okay. Dope. So, okay, we covered El Nino and La Nina, if that feels okay, Richard.
Yeah, I think I get it now.
Cool. So, okay, do we have other questions?
um, on Unit 5 MCQ Part B, like how to calculate, um, like which foods use up more water.
Okay, so let's go to part B. This is where they like try to sneak in some math, which just feels very odd. You said which number was it? Sorry.
Number 5.
Cool. Oh, okay. Do you want to talk me here? I'll show up the answers real quick. Do you want to talk, and so before we like read their explanation, do you want to talk me through like what you're seeing on the table, and like what you're reading into the question?
I know that as like, I guess the food products get more complex to grow and cultivate, it uses a lot more water. Yeah, and I think I first like went through dividing the amount of like amount of water. I don't know. I was kind of confused on like how to determine which one.
Yeah, so this one, so this is the explanation. I don't know if it's too low on my screen for you to see, but hopefully you can see it. It says vegetables require the least amount of water per kilocalorie compared to chicken meat and cow meat or eggs. So I don't think so. Like they didn't so much. They were wanting you to look in the second column here, which is kilocalories, because that's what. So it wasn't so much like it was just you having to pick out like the one that was the least in this selection. So not like least overall on the list, but just like out of these 4 options, which one uses the least amount of water?
Did I have to like take into account like the amount of water too? Because like that's kind of like the sustainable part.
What do you mean take into account the water?
Like the amount of water that each food product takes to produce that amount of kilocalories.
Yeah, so this is the amount of water. So they're saying that like for 1 kilocalorie, it takes 1.3 liters of water to produce vegetables.
Oh, okay.
Yeah, so they're saying like both of these are measurements of water, but it's just dependent on kilograms or kilocalories. And then in this scenario, they're asking only about kilocalories.
Oh, okay. So I just
Yeah.
read this table wrong.
This table is like, I think this table is meant to be tricky.
I think for me, I would logically assume vegetables because like you would need to provide feed for chickens, cows, eggs, etc. In order to produce those, which would obviously incur like you would need more water to produce an equivalent amount of like vegetables or feed.
Yeah, totally. And so yeah, and you can confirm that via the number. But yeah, logically, I think that even if they asked this, it would be like, oh, probably vegetables. Dope. Yeah, this one I remember reading and having a double take on it because I was like, I don't really get what they're asking. Okay. Other, let's see. Any other questions? Or were there certain topics that felt over like that didn't really make a lot of sense.
Oh, maybe like watersheds, because that was kind of confusing.
Ooh, okay. Let's see. Let's go off of like the questions on the exam because I could talk about watersheds all day, but they might not. The information I give might not be super relevant. So let's see, I'm gonna roll through some unit 4 multiple choice and see if I can find a watershed one. But if Richard, if you have one pinpointed, let us know.
Oh, I think it was like that same part of like desert problem, except it was talking about rivers. So I don't know if that's part of watersheds. It's question 16.
Oh, okay. Yeah, rivers are definitely part of watersheds. So let's see. Question 16. So do you know, I guess Richard, do you know the concept of like what a watershed is?
Kind of, not really. The video was like kind of vague.
Okay. So here, I'll show you a picture real quick so that it will show you. Yeah, watershed is also like kind of a vague concept in and of itself, but let me put some more concrete parameters around it. Okay. Let me share my screen. So a watershed essentially it's a confined area. But it also varies in like if you want to look at the watershed like what watershed you want to look at and what scope. So a watershed's literally like when it rains, does the drop of rain like where does it end up? Does it end up in this valley or the valley over on the other side? So like if you look in this corner here where the clouds are, where it's like pretending to rain, the rain that ends up down over here is part of this watershed that's being shown here. However, like if this drop of rain ends up on this side of the mountain, it's going to roll into the next valley, into that watershed, whatever one exists over here. And so it's just like bound by topography. So like it just depends on where the rainwater flows. And it usually ends up in like these streams and rivers is ultimately where it goes. So, does that make sense, Richard, a little bit?
Yeah, I think I get what a watershed is. It was just a
Yeah.
question that was weird.
So it says, based on the map, which of the following best explains the area of the Andes Mountains that would have the greatest number of rivers? Ooh, I remember, Caitlin, didn't we talk about this one that was like weird?
Yep. It was just all of the questions with this map on it.
This map is trash. Okay. Oh, it's the same concept that we were talking about earlier, Richard, of like which side is kind of like would have more water. So like when it says greatest number of river, it's asking you, yo, where is the most water gonna be?
Oh, so it's just like where's the most precipitation going to be on like which side?
Yeah, and like where can water exist? And so like water obviously does not exist in the desert as we examine it over here. So it has to be like on the east side.
Oh, okay, that makes sense.
Yeah, so it wouldn't be both sides because although yes, water flows downhill on both sides, but there's just like hella more water on the east side over here. Dope. Yep. Caitlin and I spent so much time on this question.
Yeah. And sometimes I still feel like I have gaps in like that knowledge, but it's okay.
Yeah, uniform is tricky. That's like last year, that was the one that students struggled on the most too. Because I don't think that y'all cover it in ES1 or ES2 with Manchante and Fields.
No, not atmospheric stuff.
Yeah. Okay, so I'll wait and see if anything else comes up for y'all as you look through kind of like your notes, but I'll just be quiet until then. And take your time because this is y'all's time to ask questions.
I think I'm good on my questions for now.
Okay. Cool. Well, this is all I have. I'll stay on for you, Richard, if you find any questions that you have.
Yeah, I don't really have any questions either.
Long pause, no questions. Dope. Well, I will post it. So I'll send you guys the link. I already posted the first on YouTube, the first half of Unit 6. But the good thing about Unit 6 is we covered a lot of Unit 6 during quarter 1. So that a lot of it should not be too new for you. So hopefully you guys get a little bit of rest during Unit 6. Yeah.
Oh
So
my God, you're right.
right.
Thank God.
Yeah. Yeah. So I'll post the link to. It's only the video that I posted is only 13 minutes long. So that takes like 6.5 minutes if you watch it on 2 times speed, which hopefully you guys are all doing. But I'll post it in the schedule and I'll also post it on Discord. So there'll be a link in both of those.
Cool.
Cool. All right, you guys are truly my heroes in doing all of this work this year. So congrats, and yeah, just let me know if you have more questions.
You got it.
Hey, bye y'all. Enjoy your Wednesday.
Bye.
Yeah,
See
bye.
ya.
Bye.